So in our second module, we will be looking for the second case study report that we had made during a fifth semester FML assignment. So basically, this module, this case study is all about predicting an heart disease, the ratio of heart disease. So in this, we'll be using decision tree classifier, and we'll be also be using confusion matrix for this. Okay. So basically, we are already using all the inbuilt Jupyter notebook libraries and all. So let's just look into the matter. So yeah, yeah. So this is basically a report for that. So the libraries that we are using out here, NumPy is basically used for 2D arrays and 3D arrays. Okay, and it is also used for many mathematical functions as such. Pandas is used for importing a data set basically, and it is also used for data manipulation and analysis thing. And with that we are using matplotlib for data visualization thing, which is it is used to plot graphs and lot of like pictorial graphical representation for that. And Seaborn is basically built on matplotlib, but it is a bit advanced, so we are also going to use Seaborn. Basically we are only going to use Seaborn. We are just importing matplotlib, and then with that we are also using imbalanced learn. What is imbalanced learn? Imbalanced learn is used for oversampling the minority classes. So yeah, basically here we can see that we are first importing all the libraries out here. Okay, so basically this is the thing that I told you. With that this is we are using pandas here. Okay, so we are using basically pandas out here to import our CSV file. So the heart.csv is one of the Kaggle, we downloaded from the Kaggle. So yeah, we had got the link for that, and then we are just going to so data.head here represents that we are only going to get the first five, because you can see that it's from 0 to 4 here. So we are just going to get the first five outputs as from that, and with the that we are also going to get the column names. Okay, now with that, when we talk about the data.info, data.info will just get the summary of the data frame. Okay, so we are getting the summary of data frame yet. So data.info is just going to get us the summary, all the column name and row name and all. Okay, with that now we are going to get the sum. For example, now data.is null here tells us the missing values in the data set. So basically we are going to get the whole count of the numbers of the row and column, or the data in the full data set where there are no entries. So yeah, so basically we are just going to get C. So all the you can say, so there is absolutely no null values in the data set. So yeah, basically where the data set is already pre-processed and is cleaned, so we don't have to do anything other than just going ahead with our model. So with that, we are just going to get the dummies. So what is dummies out here? Dummies is basically converting categorical variables into numerical variables. So that is the one. So that is the only thing that we're going to do here with dummies out here. Now, when we talk about sklearn, sklearn is also you can say library, as an inbuilt library which is used in FML, fundamental machine learning. So basically, it is used to build models. So it has a lot of variables. For example, we can use it to train models. We can use it to uh, test models. We can use it during our decision tree classifiers. We can also be using for matrices, for example, accuracy score. Then we can use it for standard scaling and also. Basically this is what we are going to use in this. So we are just importing this. So sklearn.preprocessing importing standard scaling. So with that we can just go ahead. So with that we are just going to feature the target. Okay, so basically we are just going to target the data of the target. So with that we are just going ahead. So here we have the data.head. Okay, so this is the scalar.fit transform. So it transforms the categorical data to numerical data. So now we have the whole numerical data, and we're just going to get the first five, so which is because we are using data.head, so we're just going to get the first five things. Okay, so with that we're just going to go ahead. Okay, so yeah, so now what is smart. So basically, SMOTE, the full form is SMOTE is synthetic minority oversampling technique. So basically, it is used to balance data set by generating synthetic samples for the minority classes. So basically, the classes in which there are a low amount of, you can say, information there. So we are just going to generate some hypothetical samples for that, just to get the hold of the whole data set. So with that we are just going to get the, now here this random state, it is a fixed number of random seed, you can say, which we implement. So yeah, it is 42 here, so we just use 42. With that we are just going to go ahead. And the explanation of heat map visualization. Now that we have the whole model turned in, we have the whole you can say the machine learning model turned in. Now we're going to use the Seaborn library to go ahead and you can say visualize it, just to make sure that the clients get to know about the whole constraint. So basically, when we are using the plot dot figure, so basically the PLT is plot out here, and the figure size will be 12,8. Okay, so the size of the plot hole will be 12 into 8 inches. So we are using SNS out here, it means seaborn. So we are going and heat map, so we are going to plot an heat map regarding the data. Okay, so you can see that the C map is cool bound, which is the color. So with that we are just going ahead. Okay, so this is our heat map out here. Okay, so this is our heat map out here. uh, so we can see that all the ages, the red things are the most you can say are the most complete, or you can say the most chances of having the heart disease out here. So we can see that 0.1 and the scale out here. Okay, with that we can just go ahead, and with this now we are plotting you can say a distribution plot, or you can say a line distribution plot, or you can say a line plot itself. Okay, so this is a line plot. So basically we are just going to get with the distribution of heart disease, as the says us. With that we can see that the x-axis is plotted with the target and the y-axis plotted with the count of the patients. So yeah, basically this is all the thing. Now with that, once we have this, now we will be importing the train test split, because now we have to train and test the model accordingly, because we have all the data we wanted. So now we'll be just going with the x train x test. We'll just you can say define the, or you can say introduce the functions known as x train x test, y train y test. Okay, now we are going to just test the we are just going to train the whole model to make sure that our decision tree classifier accordingly goes ahead with the thing. Okay, so now we'll just make sure that the data that we already gone is not overfitting with the model that we are making right now. So we'll just make sure that it doesn't happen. Okay, so with that, with the trading model. Okay, so we'll just go ahead and implement the decision tree classifier. Okay, from the sklearn, because sklearn is the most basic, because it also supports decision tree. So basically with that we'll have the random state 42, which is the basic thing, uh, which is also one of the variables, fixed variables, because it doesn't change. Now with that you'll have the decision tree. Now the max depth will be 5, minimum sample split will be 2, and the random state being 42 again. So yeah, basically we are just doing this again. And now with this you can see that we'll be importing many machine learning concepts like accuracy, like, sorry, accuracy, like accuracy score, precision score, recall score, and everything, F1 score, and the classifications and all. So basically with that we'll be calculating all of these things. Okay, so basically we have here the accuracy is 0.89, precision is 0.86, recall is 0.97, the F1 score is 0.91 and all. So with that we have our confusion matrix out here. How did we plot that? Basically we use this whole data, the accuracy thing. Okay, so with that we could plot it using this all, because we can see that the title is the confusion matrix, and with that we had the x label with the predicted values and the y label with the actual values. So now we have this thing out here which tells us about how the this is like how we are going to predict the whole decision thing. So, yeah. Thank you.